Today the discussion is on simulation of maximum power point tracking using boost converter in MATLAB. Perturb and observe algorithm is used for the MPPT implementation. There are basically two ways we can implement MPPT in a boost converter. First, we sense both PV voltage and current, and using these values, we implement the MPPT. The output of the MPPT will directly give the required duty ratio for the PWM generation. And this value is compared with a carrier signal and given to the gate terminal of MOSFET. In the second method, similar to the previous method, first we sense voltage and current and implement the MPPT. But here, instead of duty ratio, we get reference voltage as the output. This reference voltage compared with the actual PV voltage to find the error. This error is then fed to API controller. The output of the PI controller will give the required duty ratio for PWM generation. And this value is compared with a carrier signal and given to the gate terminal of MOSFET. Compared to the first method, this method will give you better MPPT tracking performance since it has a closed loop control mechanism. This method used in the simulation that I am going to demonstrate. This is the MPPT algorithm flowchart that we are going to simulate now. You can pause the video and try to understand this. Now I will show you how I designed the boost converter. First I will give the specification of the circuit. The solar operating voltage range is between 250 volt and 350 volt. Input current is rated power divided by input voltage. That is 400 ampere. Therefore the current ripple is 5% of 400 amps. That is 20 amps. Now voltage ripple is 1% of the output voltage. That is 6 volt. Output current is given by rated power divided by the output voltage. That will give 166 amps. Now we will calculate the inductance and capacitance of the boost converter. The equation that I am using here is taken from the textbook Power Electronics by Muhammad H. Rashid. Value of inductance is given by L is equal to V input into V output minus V input divided by FSW into delta I into V output. That will give 1.45 millihenry. Value of capacitance is given by C is equal to I output into V output minus V input divided by FSW into delta V into V output. That will give 3227 microfarad. Now we open the MATLAB and start doing simulation. First we add the PV array. Set the number of series and parallel strings. This is the MPP voltage and maximum power at 1000 watt per meter square radians. This is the same values for 500 watt per meter square radians. This is for 100 watt per meter square radians. Open circuit voltage is 363 volt. Set a radiance 1000 and temperature 25 degree. Name the PV voltage and current. Connect DC input capacitor. Set some random values. 1000 microfarad is used here. This is the boost inductor. Set the designed value, that is 1.45 millihenry. Now connect an IGBT. Now connect a diode. Connect filter capacitor. Set the designed value, that is 3227 microfarad. Connect a load at the output. Set its value to ohms. Connect unit delay block. Now I start writing the code for MPPT. So that completes the code for MPPT. Now add a sum block. Connect API controller. Set its KP and KI values.
Add a repeating sequence.
Set the switching frequency and amplitude of the carrier signal. This block displays the power generated by the solar PV array. Set simulation in discrete mode and sampling time 1 microsecond. Now we run the simulation. There is an error in the MPPT code, so I will correct that. This letter has to be in capital. Here you can see the power generated by the solar panel. For 1000 irradiation, the maximum power is 100 kilowatt. So we will see if it reaches that point. As you see, the power has reached 100 kilowatt. So the MPPT is working fine. The same can view in the scope also. Now we will see how the MPPT responds when we change the irradiation while running. Changing irradiation to 500 watt per meter square. The corresponding MPPT point is 500 kilowatt. So the power has to reach that value. Now the power has changed to new MPPT point. Now I will try a different irradiation. The power has reached 60 kilowatt, that is the MPP point for 600 irradiation. Now I will change the irradiation to 1000. So the power has to reach 100 kilowatt. Let's see if that happens. So the power has reached 100 kilowatt. Now we will see how it responds to temperature variation. Since I have increased the temperature, the power has come down. When I go back to the previous temperature, power also going back to the previous value. This is the end of this presentation. Thanks for watching.